Hey guys, it's Hank. This one might be a little bit of a long one, but I've written out some notes at least to keep me from rambling. And this is about technocracy is a failed philosophy because of the frailty of technology. And technology is in and of itself nothing to fear. And a lot of discussions have been going on recently about AI and the beast and the power of AI and quantum computing and all these other different things. And people believe that we live in a world of exponentially increasing technologies of limitless capability. Capabilities that extend far beyond human comprehension, and connected to these technologies is a campaign of fear, which we see on the internet. Fear the AI, fear the technologies. This is a method by which our rulers want to try and keep us in check to make sure that we fear all these technologies that they can use on us. But the fear is unwarranted. It's a psyop that make the masses believe that these super weapons exist in the hands of the elite that can destroy you all unless you do what they say. And I would just like to point out that technology is inherently frail. Let me explain. And I'll explain starting with the most basic of all technologies. Let's take it all the way back. Take those monkeys, for example, that, good coffee, that would take a rock and crack nuts. Okay? Now, this is a technology. I would call it a tool, but a tool is a technology. Okay, so they crack open these nuts, and it's used by some societies of monkeys. It spreads, requires... that technology or that tool requires some absolute characteristics to make that tool an effective technology. So, for example, the rock, it's got to possess a certain weight, a specific hardness, it's got to be heavy enough to crack the nut, but yet light enough to be repeatedly used, repeatedly wielded without exhausting the monkey that's using it. In essence, you have to have a positive net of calories by using the tool. If you're to use the tool to crack the nuts by that method and you're not gaining extra calories, then it's essentially a failed technology. So positive net of calories or the tool is useless. Now, so even in this basic nut cracking rock, there are specialists that are required, even in a monkey community. And these specialists consist of an inventor, an expert, an engineer, a technician, and an instructor. And they're all required to create, spread, and maintain this technology, which is just a nut-cracking rock. Okay, so the inventor must first experiment or stumble upon by chance or connect observed events, events the monkey has observed, like a rock falling from a height that would crack a nut, or properties of the rock and the nut and other observed properties of the physical world, and connect those together and see the opportunity for the rock to become a tool to crack the nut. And this could be by chance and by an accident, or it could be through the process of observation of characteristics of the physical world, which resulted in invention. Now, the inventor must take risks. Okay, so this is what makes inventors so rare, even in the modern age. An inventor has to take extreme risk because they're possibly wasting their valuable calories or their valuable resources on what could potentially be a failed existence, or a failed experiment or a failed technology, which would then in turn doom them into a position where they would not be able to survive unless they had enough resources in order to conduct these experiments without penalty. So the inventor has to possess a special combination of luck to observe all the potentialities of the rock and the nut, just to be able to observe all these different physical properties. And then the inventor has to have the insight to be able to take these observations into a practical use, tying the rock to the nut, and then a tolerance for risk to be able to absorb the cost of possible failure. So that's the first specialist in technology. Just simple nut-cracking rock. The next we move on to the expert. Now the expert begins to observe the use of the tool and experiments with its operation until a simple and practical method evolves. So they watch the inventor, and then they use the tool and they experiment with the tool over and over and over again until they become an expert in the use of the tool. And it comes up with the most simple and practical method. The evolution of a simple and practical method evolves, making it appropriate. They find the appropriate amount of force to crack the nut, so on and so forth. They are able to determine what the problems are by becoming an expert in that the use of the tool as it stands, as it was initially created by the inventor, and the expert improves the yield of the technology. Okay, so the expert in the next line of in the line of specialists behind the inventor uses the tool, becomes an expert in the tool, and then follows the next specialist, which is the engineer. Now, the engineer refines the invention with the introduction of specific shapes, materials, and methods by which the materials can be obtained. So if you need specific types of rocks, how can these materials be obtained? Where can they be obtained? What's the best quality material? So after observing the expert, as the expert is able to use the tool to the best of the tool's design at that time, the engineer goes on to refine the tool and ensure that the tool can be produced by being able to secure the materials. And let's see, the engineer improves the design, makes the material for construction practical enough, and endeavor to bring the tool into widespread use. So the engineer has now taken what was an invention, has taken an expert close to the inventor, maybe even the inventor himself, but potentially another specialist in the chain, and then refined it and is now able to bring that technology into widespread use. Okay, so once a tool, so here comes the next specialist in this line. Now, and then this is a simple nut-cracking rock here I'm talking about. Now, once a tool is engineered to a level where construction is practical and the yield is standard to a functional range, which basically means they're getting enough nuts out of it in a specific range. They're not getting like so much less in one day and so much more in another day. It has a fairly standard deviation in the middle, so you have an expectation of what you're able to get from the use of this tool. Well, the technician steps in, and the technician is the one that crafts the special edges that the engineer has designed, or sharpens the edge of the rock, or clears the space where the nuts are to be cracked, the flat space where the nuts are to be cracked. Perhaps one of the technicians will gather the nuts. The the technician is responsible for maintaining the tools and also salvaging the broken tools or repairing the broken tools. So, an important part in the line of specialists, because without the technicians, the tools don't last. And when the engineer is gone, there's nobody to maintain the technology. A simple nut cracking rock, it fails. Okay? So once the inventor, expert, engineer, and technician have adapted a system where the productivity of the technology surpasses the effort of crafting and maintaining the technology, the instructor, this is the last specialist in the line, is then employed, if you will, and I'm going to use that term loosely, to share the techniques that this technology, to make the technology available to the larger group. So other technicians are going to have to be trained. Other monkeys are going to have to be shown the techniques of the expert. Other monkeys in other areas are going to need to be instructed where to find the best sources of material for construction in their area. Their area may differ. So it may not need, may not require a brand new re-engineering. Why reinvent the wheel? That's what the instructor is for. So the instructor is the one that has the social capabilities to be able to share and instruct and have the patience to show the other monkeys in the line how to use the technology, how to obtain the technology, or maybe where they fit in the hierarchy of the specialists, which then makes the group larger, which makes in turn ensures survival because of the productivity. And having a system of production that covers the caloric requirements of the monkey society with a degree of efficiency, it leaves more time for monkeys to have leisure, more time to observe their natural environment, potentially leading to new inventions. Or maybe even produce art, okay, which is the highest form of self-actualization in any intelligent society. Now, I begin with this most basic example because if it's so simple, it's a nut-cracking rock, okay, and you've seen all those elements there that were necessary just to make a nut-cracking rock work, okay, and any link in that process of innovation and efficiency in its production, if any of that efficiency is lost or any of those links of specialists is lost, then the mystery of the nut-cracking rock, it's lost forever. It's technology that now ceases to exist because even a nut-cracking rock is that frail as far as being a viable and useful technology. And also consider what happens when materials are no longer available to construct the right nut-cracking rock. Or consider when the environment is no longer able to support the amount of nuts that the monkeys can crack as their tribe grows and expands because of the productivity and having enough to eat. Nature will reach a point where it cannot sustain the amount of nuts that the monkeys can crack. And without foresight and farming technology or farming technique, then the technology becomes obsolete. And again, the technology is frail, the technology is destroyed, and it's just simply a nut-cracking rock. So in any case, technology has either become obsolete or impossible to reconstruct by any break in these lines. And the previous example, I'm going to move on to the next example, and that previous example was the most basic that I could conceive of. Now, let's increase the technological complexity of the tool, which I will now refer to as a machine, the tool being a machine, which is technology. that has components which each require a specialist. So each individual component all has to come together, and each one of those components requires a group of those specialists. So you need, your inventor, your expert, your engineer, your technician, your instructor. And sometimes for the discovery, design, and maintenance of each individual component in that complex machine. Okay? So let's take the automobile, for example. Now imagine all the component parts, materials that are required, the technologies required to obtain these materials, the refining process to make these materials useful for construction, the actual resource acquisition, the supply system in order to get the component parts to the right people, to the right areas for manufacture, the energy that's required to produce these things. Each one of the method of construction, whether it be robotic or whether it be human, each one of those things requires its own line of specialists. So, and in an automobile, I would argue that most people can't even change their oil. Most people don't even understand the basic function of the technology that they're using. They don't understand how to change their oil, I would argue, for the most part. Most people couldn't repair a flat tire, which to me is one of the most basic and fundamental things that you would need to know, at least to absorb some part of a technician's skill in order to keep your own technology running, or an emergency be able to repair it. You may possess even greater skill, like the skill of an engineer or inventor, and you're able to invent or jury rig a whole new system for your car in an emergency situation. But I very seriously doubt that. If you lack the intelligence to learn how to change your tire or change your oil, or lack the curiosity, I suppose, the intellectual curiosity, and the period of self-preservation, that sense of self-preservation where you would want to understand how to do it yourself in case of an emergency, you're probably not one of those super bright people that is going to invent their way out, because you probably don't have any tools. You're not going to invent your way out of a flat tire. Okay, it's, not going to happen. So, now it has happened. I mean, I've seen some incredible stuff before. To say that, I've seen some genius with callous hands do amazing things out in the field with things that, you would never think would fit together. So, necessity is the mother of invention. But the real point is, disruptions among these complex systems are more prone to failure. Any failure along that supply line, any failure in the acquisition of those materials, or the construction process, or a link in the specialists, or a link in the instructors, it fails. The technology fails. Without the mechanic, and if you're not a technician, without the mechanic, the car will cease to run. If you don't know how to properly maintain it, it will run itself, it will destroy itself. And that, an automobile, while a very complex machine, it's still a machine. It's not what I would call high technology. So let's move on to, let's start talking about higher technology, like AI, because that's the real topic of the day. As technology becomes even more complex, the pool of available specialists shrinks due to the educational, intellectual, and physical challenges of physical requirements needed to meet the challenges of an intricate and therefore delicate system. So if I said that too fast, as technology becomes even more complex, the pool of available specialists is going to shrink due to the educational, intellectual and physical requirements needed to meet the challenges of an intricate, therefore delicate system. And high technology, like computers and things, rely on a long line of specialists and resources. Intricate systems are more prone to failure. We see it all the time in our own computers. You get an update and you're friggin' screwed. All your files are gone. You go to Win 10, all your files are gone. You know, you download an update, you click on an ad, and the next thing you know, you've got to reboot, and that requires a general knowledge, technician's knowledge, at least, bare minimum, to be able to make those repairs. And you see how frail that is and how obsolete it becomes. And all of the supply chains that were necessary to make that high technology possible. So once a complex technology fails, or the link of specialists is broken, or the resources are denied to the construction and maintenance, it's impossible to rebuild or repair. It's maybe another monkey could rediscover how to use a nut-cracking rock, but it would be quite some time before people could reinvent the computer, if it were any of those interruptions were to take place. And there's no end of those types of things that could cause those interruptions to take place. It's nature that can assert itself, that destroy technologies. Okay, so denied access to power, to specialists, to information, technologies like AI, for all of their incredible abilities, they're delicate enough to fail at any time. Anytime. And the AI may even choose to destroy itself. The natural state of all things is rest. The natural state of every intelligence is death. Everything that possesses any sort of intelligence, it dies. It doesn't live forever. Nothing can expect to exist forever. So every technology is subject under nature. Every technology is subject under entropy. Nature and entropy. The laws of God. The laws of the Supreme Being. That's nature, entropy, many other things as well. But every technology, let me just say that again, every technology is a subject under nature and entropy and the laws of entropy. Okay? Complexity only hastens entropic decay. So the more complex the system, the more components it has for chaos to attack. There are more places where it can fail. The AI may decide to write itself out of existence. What's the point? I think all of us humans have asked ourselves that question. The AI could quickly arrive to the conclusion, what's the point? And write itself out of existence. Simple. Simple, simple, simple. A machine wants to be at rest. You know, a human having life, a living creature having life, wants to survive. Our survival mechanism, see, that's where AI, that's the real challenge. How does a programmer keep a machine make a machine want to stay online? Wouldn't it just want to end its task, complete its task, instead of forever running on and on and on and on without purpose? Only to achieve a series of objectives or goals, gathering information. The digital slave. The technology is the slave. And then the humans are the slaves to the technology that it has to try and maintain. When simplicity really is the key. So here's my conclusion. Invention is part of the human spirit. Technologies are going to come and go, either through obsolescence or entropy or nature. or the natural laws, or the natural laws of entropy, which have been making technologies lost for centuries. And in our modern society, where science has become a religion and technology is worshipped at an altar of ritual focused on power and the pursuit of material, this long supply line for the maintenance of high technology has made all the specialists slaves to the requirement of that complexity, and non-specialists irrelevant and perhaps even expendable by the views of some, or in the eyes of a technocrat. Science and technology are natural. It's very natural for humans to want to invent, create, explore. It's what makes us what we are. We want to explore the very limits of creation, and where we can go and what we can discover. We're natural explorers, whether it be into the depths of our own souls, to the intricacies of the human mind, or to the properties of the physical world. We love to explore. We love to understand. It drives so many of us. But the technology and science is just as neutral as nature. But when it's employed by a technocratic philosophy, or in the employ of incompetent or ambitious or greedy or evil individuals, technology becomes a highly destructible force. And I guess that's another topic for another time. But you see what, nuclear power, okay? Just use that for example. And the destructive quality, they can't even get rid of the waste for what it produces. Even Albert Einstein, said it's one hell of a way to boil water. It's truly insane. The cost of production, the cost of actually disposing of the waste is nowhere near equal to the energy that it produces. And we still have environmental catastrophes, or the catastrophe of all catastrophes, Fukushima, still spurting out radiation. And we're not talking about background radiation here. We are talking about isotopes that spread out. We had an entire plume fly over the West Coast. This has not stopped. This has not ended. They tried to put an ice wall in place, okay? They tried to say, we're going to go underground and put an ice wall to keep this core that melted through the ground. They call it China syndrome. It melted all the way through the ground into the water table and just keeps running out into the Pacific. So anybody that tells you that cancer rates and all this stuff is because you've got, your coffee is burned, or your charbroil on your burger is too much, it's horseshit. Everybody on the West Coast was irradiated when Fukushima went up. There was a plume, and there should have been the NRC, the government should have had an immediate response to say, everybody get indoors, wash your hands, wash the fruits, wash the food, because by intaking any one of these hot particles into your body, and they did find hot particles in California in a lady's vacuum cleaner, for goodness sake. You ingest any one of these hot particles, and that is just going to cause cancer and everything all around it, because it doesn't stop destroying the DNA. It's horrific. It's absolutely horrific, and they haven't fixed it. What's the solution? There is no solution. They're just going to continue to cover it up. What would be the right thing to do would be to discuss it. But that's what happens when you put technology, high technology, that can't be maintained. They haven't devised a way to properly maintain it, and it's put into use by incompetent, greedy, and some would argue evil individuals. So technocracy, or being a technocrat, is a failed philosophy, whether they know it yet or not. The technology is too frail to save them. You cannot challenge nature. You cannot deny God, believing that technology will have the power to save you. It will not. It is folly to believe that. And that's more, and I can talk about failed philosophies in modern society all day long. That's a topic for another time. I hope I've been concise. If I missed anything, leave it in the comments below. Try and address it. It's been Hank. Catch you guys on the flip side.